everyone. My name is Andrew Summers. Today I'm going to be talking about domain-specific languages and metaprogramming. Before we begin, though, actually, who has never programmed in Elixir before? Who's pretty new to Elixir? Who's maintaining some sizable apps in production? And who's like expert Elixir person? Alright, we have a good mixture of folks. There aren't going to be too many Elixir-specific things in here. There is going to be some Elixir code. Ask questions at the end if needed, but I hope some of it's going to be pretty language agnostic, but we'll see. Alright, so my name is Andrew Summers. I'm a software engineer at DRW. We are right around the corner on Clinton and Madison. I wrote the Dialyzer Pretty Printer for making the error messages from Dialyzer be comprehensible. And I maintain Dialyzer, the Erlix package that powers Dialyzer, and then the maintainer somewhat of the Elixir LSP packages for making your editor and Elixir talk to each other. And then look out for me on GitHub. I'm all over the place, fixing bugs, filing bugs, telling people things. I don't know. Well, I'm all over it. Okay, so for my topic today, we're going to talk about what a DSL is. We're going to talk about modules as data structures. We're going to go into macros a little bit. And we're actually going to build a DSL, so that should be fun. All right. So DSL is a domain-specific language, and what it allows you to do is talk in the language of people in whatever domain that you happen to be in. You know, whether you're in finance, whether you're in web, whether you're in SQL, and it lets them kind of communicate at a vocabulary that's familiar to them that may not be a language keyword. Us being an Elixir, we have macros, so that affords us some capabilities to be able to do that a little bit better because we can hide away some of the plumbing. And some good examples of DSLs in the ecosystem are Ecto, which if you use Elixir at any point in time, you've probably used at some point. And Absinthe, which is the GraphQL implementation. They're very different under the hood. I have opinions about which way I like doing things better, but I guess you'll see that coming up. So why would somebody want to create a DSL? As an example, if you have Ecto, you might want to attach some extra things to that. So I might have descriptions about one of my fields. I might just have some extraneous information that I want to somehow, like I just have a superset of the information that needed in order to create one of these other DSLs, or I might have some entirely extra set of information that I just need to communicate with some experts in some capacity, whether that be a math library or what have you. Having a DSL also allows you to edit your code base in one fell swoop. You get some nice kind of compilation things out of it. By having a shim and having a language in which your entire code base talks to, it gives you some really nice editing capabilities. And then sometimes just making these data structures is not fun, and you want to plumb those behind some macros, and you want to just hide away some of the giant struct creation monstrosity that might exist within your code base. And then once you have a DSL, you can do some really cool things, and you can create some very generic pipelines by asking your DSL objects about themselves, and when they can give you some information, you can just interrogate them and do some really cool things, like create documentation, for example, in the description thing that I was talking about earlier with Ecto. Yeah, once you have a DSL, you can do a lot of cool stuff. However, most of the time you don't actually want to do this. Really don't need it most of the time. And in particular, if you're just starting your application, you probably shouldn't be building one. You kind of want to wait until you get some pain points within the actual construction of your code that requires you to actually go and create one of these things in order to hide away some plumbing, hide away some pain points, hide away just some bugs that people are dealing with when they're interacting within your code. And in particular, you should really wait until you have some decent data structures under the hood before you do it. Some people go top down with their DSLs. I do not recommend that in any capacity. I recommend going bottom up from the data structures and then kind of putting a nice facade over top of the data structures. It really, if you do it the other way, you can kind of get into trouble. I mentioned Absinthe earlier. They kind of went top down with it, which is a reasonable approach, but under the hood, some of their data structures are a little hard to work with, and in particular, some of the decisions that they made in order to do that don't allow the ability to embed absent schemas within another DSL, as an example. Whereas Ecto, on the other hand, they went bottom up. They started with their associations and their fields and all of those things, and because of that, you can embed that within another DSL that you happen to have. So yeah, you probably don't need a DSL, but since you're here, I'm going to tell you about them. So modules as data structures. This is a really cool pattern that I don't really see talked about too often in the community. If you have a module, you can do what's called registering an attribute. And a module attribute, for people that are unaware, is these little @ symbols right here. You can either have them accumulate, which means that if I have this foo's A and foo's B, foo's B will not overwrite foo's A. You'll get a list. And whereas bar in this example is a non-accumulating module attribute. So when you say C and then you say bar is again D, that overwrites the value of C. You use them for different things, so you might give a default in one of your DSLs and then want to override it with your own module attribute. Ecto does this with its primary key and a couple other things, but they're used for different things. But the cool thing is, once you have these, they're just data structures. They're just structs, they're just maps, they're just numbers, they're just strings, and you can just put them into functions at compile time, and then they're in your module now. And because they're functions, you're exposing them outside of your module, whereas if you didn't throw them into a function, you couldn't really interrogate them after the fact. So in building a DSL, we use this all the time. This is the vehicle by which you really accomplish this whole endeavor. Yeah. So the manner by which you here, we just kind of we have the foods and bar module attributes, but if you just have inside of a function, you pass the module in and call module.putAttribute on it, and just give it a name and give it the thing that you're trying to put into it, validate the ops, and kind of go to town from there. So a good example of this is if you look in the ecto.schema module in Ecto, the __schema __, there's a couple different variations of that. So you can ask for its fields, you can ask for its relationships, and there's a couple other things, primary key, and because they get exposed in the module itself, you can just ask it questions. And if you decide to not use one of these underscore functions, which will make it not show up in the documentation, you can actually throw a behavior in front of it, which will give you some cool things with compile time safety in the event one of your modules doesn't actually implement one of these functions. And again, at the end, we're really just want to ask this module a question and then do stuff with that information. For use in like generic pipelines. So as an example, one might want to create a change set by just asking a module questions about itself. It might be able to tell you what all the required fields are, at which point you can, just by passing it the module, you can ask it what its required fields are and then obviate that ecto validate required line from your code. So macros. This is the fun one that people don't usually see. Truthfully, a macro is just I give you an abstract syntax tree, and you give me an abstract syntax tree back. It should be a valid abstract syntax tree. But what this lets you do is this lets you grow the language past the point where the creators of the language knew about what you wanted to do. There's a really good Guy Steele talk for his Turing Award lecture several years ago, where he only spoke in monosyllabic words, and then built from those monosyllabic words rules about how to create bisyllabic words and trisyllabic words, and he basically grew enough vocabulary within his talk to be able to actually give a good computer science presentation to a bunch of PhDs and stuff in the room. So it's a really good talk, and I encourage you to go seek it out. It's worth the 45 minutes of your time. But when you're doing macros, there's some stuff that you can do to make your life a little bit easier. So in particular, because macros are happening at compile time, you really don't want to do that much work in them. Sometimes you need to, sometimes you do need to do a little bit of work, sometimes there's some things that you need to do in order to gather some data in order to pass it into a function, but you want to delegate out into functions as soon as humanly possible. If you do that, you'll start to get better error messages, and you'll be able to actually go and debug things and get some same information from the compiler when you're doing something egregiously terrible, which most of the time happens when you're unfamiliar with macros. There's some shenanigans that you can get into. One thing that I don't really see very often in live code in the ecosystem, there's an op that you can pass into your quote blocks in a macro called location keep, and what that does is it says, okay, so because a macro is just embedding a bunch of code into your module, if you don't include location keep, what it's going to do is it's going to offset your line numbers in your own module by the contents of that quote body. And so when you use location keep, it limits to that single line, and so you don't have to subtract 100 from any line number error message that you happen to get from the compiler, which is super helpful because most of the time that's what you want. I can think of very few scenarios where I actually don't want to use location keep, and usually those are just because they're embedded macros somewhere and none of that is exposed. But at the top level, most macros that you want to use, you want to have location keep there. You should also make sure that when you're building some of these macros, you validate your input, especially unnecessary ops. There's nothing more painful than when you're using a library and you pass it a bunch of fields and options that it doesn't need, and it doesn't tell you that it doesn't need, and you think it's doing something. Like you can pass like null, true, and false to an ecto field that doesn't actually do anything, but it looks nice and it's helpful to the reader. But it doesn't do anything to your program. It imparts a false sense of security to your reader that it's actually doing something that it's not. And in general, avoid dynamic name generation. Don't concatenate module names in the middle of your macros. You want to be able to grep for things, especially because we're generating code and shoving it into your module. The less things that we have to create whole cloth, the better. There's some libraries in the ecosystem that definitely do that, and it's always difficult when I can't grep for the module name with something that's happening in my code. And sometimes you need to do some really dirty things too. So the compiler is really useful for saying, okay, I have module A and it points to module B. So when module B changes, module A might need to recompile itself, or vice versa. But when you have two modules that point to each other, so in an ecto schema, for an example, a user might have an address, and an address might have many users. Which of those do you compile first? You get into a compiler deadlock. And so disabling the lexical tracker is useful for making that problem go away. However, it's also a very dirty thing to do, and you can get into trouble because you're removing the compiler's ability to recompile things, and so you have to deal with that different ways. And you often have to wind up doing full recompiles more often than you would like if you use this more often than you need to. So data. I'm of the school of thought that data is significantly better than code, is significantly better than macros. I know a lot of people that disagree with this hierarchy. This is actually a Lisp idiom, and the whole notion behind this is if I have a data structure, I can create code around it. If I have code, I can create macros around it in ways that can't happen in the reverse direction. So if I have a macro, I can't really pull the code out of it and do stuff with it. I kind of just have to deal with all the stuff that you put into your macro. And similarly, if you just embed some data structures in the middle of your code, I can't do anything with that. I can't interact with this in unexpected ways. And so because the whole exercise here is growing your language and growing your code in unforeseen ways, I think that this is the hierarchy that exists, at least in my brain. I really encourage having good data structures, and from there, building everything on top. And I would argue that DSLs are really the marriage of all three of these things. You can have data and code, but that's just code, right? That's just normal Elixir programming. You can have code and macros, but then that's not super useful because you can't really extend that in artificial ways. And so it's really having a nice balance of all three of these concepts that you get cool power in building a DSL. All right, so finally, we're going to create a DSL. We want to, like I was saying earlier, we might have some descriptions about things, and we want to embed that in our own ecto wrapper kind of thing. We want relationship field semantics, but we have a superset of information that would be required in order to actually create one of these ecto schemas, and we want to expose that to our program in some fashion. You can throw it into a function, but after a while, again, the plumbing starts to get a little painful for that, and you might want to do some more things. And you might not want to necessarily maintain this active schema as well as these other functions. There are definitely circumstances in which you would want to wrap one of these things. So this is what we're going to be building. So instead of the schema, we now have a table. It's got the same semantics as an ecto schema. Attribute is analogous to field. But notice that it has a description, it has a required, true or false, and then we just have a normal plain old attribute, which is analogous to just a normal field. It doesn't have anything special. And then we have the description of the whole table itself. So this is the end goal. Let's see if we can get there. So again, start with the data structure. You might have a thing called I'm going to call it ec2 is the name of my fun little DSL. So it's only got a couple fields, pretty simple. Might have some more stuff in that module, but it's not useful to us right now. And we're going to have a relationship. I omitted many to many because it's harder, and didn't want to deal with that for purposes of this slide. Or for purposes of this presentation, rather. But otherwise, it's basically the same, except that you can have a description. I didn't use that in the actual thing that we were building, but we'll go into some of the parts about how you would want to build one of these more complicated structures rather than just a field, even though I didn't actually want to do that. So, with the registering attributes, we have a couple of module attributes that we want to use. So we have a description, we have a table, and then for our accumulating ones, we have some attributes and we have some relationships as well. One might imagine that you want to have more things in there. So you might want to have some metadata and things like that. But again, for purposes of this, we're just going to stick with these four. Should be illustrative enough. And notice again the location heap. Because when I do that table, I just want that module, or I want the line number to exist properly within that module. Okay, so picking up at the bottom, right below these module attributes, this is really the meat of how everything kind of works. So given the name that we pass into this def macro at the top. We're going to just shove that straight up into our ec2 table name, into our ec2 table module attribute, and then we're going to import all the macros in our module. So we'll get to the macros that exist, but if we go back a couple slides, notice that I only brought in table. That was the only thing that I actually needed in order to do this stuff. Everything else is brought in after the fact, and that happens right here when I say import ec2 table. This try block here is important when you make a mistake when you're building one of these. Otherwise, the compiler can just hang and it can say, "Oh, I'm expecting some more." I'm just sitting here waiting, and most of the time it's not appropriate. So if you throw a try block around the unquoting of the body, that will usually do what you want, and it'll crash appropriately, I guess. And then at the end, because we're good citizens, we're gonna unimport all of our macros and make it so that nobody can call my description macro again, or my attribute macro again, or really anything else past the point that it's actually going to be useful. We'll get a compiler error if you try and use one of those things outside of the table definition. Okay, so our attribute block, we're just going to delegate out to a public function with underscores. One might expect that, in a sufficiently larger attribute, you want to validate some ops. You can call it, because we're just in a function, you can do that. You can just call it to a function, in this module or any other module. But really, we're just making one of these data structures, and then we're shoving it back into this ec2 attributes function, or into this ec2 attributes module attribute. And that's pretty much it, right? Like, this just gives us the data structure, and because we now have this data structure, we can do stuff with it, and we can ask it questions. It's a struct. We get nice compile time guarantees if we try and access keys that it doesn't have. There's a lot of nice stuff that comes from kind of doing it this way. Again, I encourage you to validate your ops and make sure that people are only including the attribute or the ops that can exist within your struct, and also that they're the right shape. If you're embedding a map in there or something, you might want to say that it has certain keys or what have you. I don't know your life, and I'm not going to tell you how your code works. But you can definitely get kind of more exotic with some of these validations, and that's kind of where you would want to do something like that. All right. The description one's a little bit simpler. We just have a name. That should just say description. My apologies. That name is not used. And we just call out into our description module, and that just shoves it into our description module attribute, and we call it a day. At this point, now we have a description that we can use to go and create the rest of everything. This is the disabling of the lexical tracker thing that I was kind of talking about. Inside of Ecto, they actually changed this a little bit, and I didn't quite understand how they changed it. This used to be how it looked, so I just went with this because I can actually understand this. And it's pretty much just saying that the lexical tracker is nil. Usually that'll have a list of modules. I think it's a list of modules that your module is tracking, and as you alias things and as you reference modules, it'll just shove it into your end under that that attribute. So again, if going back to what I was saying, if I have a user and they have addresses, and addresses have a user, which of these do we compile first? With a field, we don't really have that issue. It's just a bunch of data. It doesn't really it could, but it doesn't necessarily reference other modules. But for a relationship, you're going to run into that problem a lot. And so you would want to do that right before your quote block, and just say that on referencing this, this other module, we just don't want to do that anymore. And that's the vehicle that you would get out of that compiler deadlock. This should have a description in it, but you can imagine that one of the ops here is description, and you would just shove that into the relationship struct. And again, we're just shoving it into our accumulating module attribute, into the ec2 relationships module attribute, and calling it a day. So at the end of this, we might go and say that we want to take all of our accumulated ec2 attributes and shove them into the attributes function. We might want to take our description, shove it into the description function. Belongs to your relationship, same thing. You guys can read. And from here, now I have the ability to interrogate this module that I'm building. I can ask it, what's your description? And I can shove that into an HTML document somewhere in Phoenix. Or I can say, what are your attributes? And instead of the pattern that you typically see in a lot of Ecto schemas is people shove it into a module attribute at the top and then shove it into their change set. You don't even do that. Just ask the function for it. Say like, hey, module.attributes, or give me the list right here, and we can do stuff with them and build a generic change set as an example. But what's really cool is now that we have all this, we can just build an ecto schema. So with our ect2table function, with our ect2table attribute, we just make a schema out of it. We called it example in the one that we gave before, but that's analogous to our schema table. Our attributes, same thing. But notice, of course, that we're not actually using some of the additional fields that we threw into this, but that's okay. Ecto doesn't have a description field in their field or in any of their relationships, but we do. We have that information, but now we're just saying, okay, ecto, go forth and do ecto things, and giving it the subset of information that it needs in order to do its job. And again, so this is what we kind of built. Yeah, so that is what DSLs are and why you want to build one. We use module attributes as a vehicle to collect compile time data. We talked about macros, and we built a nice little wrapper around ecto. And we might want to, expand those data structures a little bit. We might want to give it, for example, JSON schema validation, and use that in building a web pipeline. Or you might want to. There's really all sorts of things that you would want to do in expanding these data structures to fit your problem domain. And you can build helpers to ask common questions about that data. So you might say like, oh, have a helper to go and fetch me all the JSON schemas out of my fields. Or you want to, again, build a generic pipeline in order to create like a default change set or something like that, so that you only have one place in your code that you actually have to look in order to deal with change sets within your code. And then you could add more esoteric macros to enable more sophisticated generic pipelines, because you as the application developer, you know what data you have, you know what data you need in order to go and deal with your program. You can just add more macros in the exact same way, shove it into a module attribute, and kind of call it a day. Thanks.